Class 10 multiplexer. Experiment number 7. Multiplexer means many to one. Means many inputs, one output. Example, you have here 4 inputs, 1 output. 4 inputs, 1 output. Four inputs, input 0, input 1, input 2, input 3 and 1 output. This is called 4 into 1 multiplexer or 4:1. It is also written as 4:1. For example, like this, 4:1. Four is to 1 or 4 into 1. You can write anyway. Multiplexer is shortly written as MUX. So, which input should be pushed to the output? That depends upon the address selected by the circuit. You have here select or address inputs S0 and S1. S1 is MSB, S0 is LSB. Each input has an address designated by these select inputs. When S1 and S0 are 0, 0, input 0 will be selected. When S1 and S0 are 0, 1, input 1 will be selected. Means when S1 and when it is 0, 0, input 0 will come to output. For 0, 1, input 1 will be moved into the output. 1, 0, input 2 will be taken to the output. The word is usually called as steered. For the selected address, the relevant respective input is steered into the output line. That is the usual sentence. ನಿಮಗೆ ಅರ್ಥ ಆಗಲಿಕ್ಕೆ ಹೇಳೋದಿಷ್ಟು, ಅಡ್ರೆಸ್ ವ್ಯಾಲ್ಯೂ ಎಷ್ಟಿರುತ್ತೆ ಅದಕ್ಕನುಸಾರವಾಗಿ ಈ ಇನ್ಪುಟ್ ಸಿಲೆಕ್ಟ್ ಆದ ಇನ್ಪುಟ್ ಔಟ್ಪುಟ್ಗೆ ಟ್ರಾನ್ಸ್ಫರ್ ಆಗುತ್ತೆ. So in the circuit you have IC 74153. 74153 is actually in the pin diagram is here. It is dual 4:1 multiplexer, means there are two multiplexers, each 4:1. See here, output are designated as Y, input as D0, D1, D2, D3. Address bits are shown as S0 and S1, sometimes AB. In this chip it is S0 and S1. See here, pin number 14 is S0, pin number 2 is S1. The data of first multiplexer is 1D, that is 1D0 to 1D3. Data of second multiplexer is 2D, that is 2D3 to 2D0. It is always better to say 1D3 to 1D0, 2D3 to 2D0. Better always say the MSB first. Now when S0 and S1, the S0 and S1 are common for both the multiplexers. When you make 1G active, first multiplexer inputs D0, D3 to D0 will be operating. When we make 2G as enabled, 2G bar as enabled, the inputs 2D3 to 2D0 will be active, and according to the value of S0 and S1, that will be selected to the output. Output 2Y. In the first case, output will come to 1Y. In the second case, output will come to 2Y. And VCC and ground, here VCC is called as VDD, pin number 16, and pin number 8 is ground. The internal diagram is here. You can see here there are two sets of multiplexers. See here, data inputs 1C3 to 1C0. Okay, so that there what D is there, the same here is, it is shown as C. So 1D3 to 1D0 or 1C3 to 1D0, 1C0, both are same. Next 2C3 to 2C0 or 2D3 to 2D0, both are same. S0 and S1 are shown here as A and B. You can see here address inputs as A and B here. A select, B select. Pin number same, 14 and 2. 2 is MSB, the bit B or S1. 14 is bit number LSB. A, you can see here, select inputs. S0 and S1 and S0 or BA. Now here G is the strobe input or enable input. See, for the first multiplexer it is G1 or 1G bar. Actually it should be written as G1 bar. You can see here there is bubble. Means when you make G1 as 0, the first part will be active. Similarly, when you make G2 or 2G as low, the second one will be active. At a time, if you make both active, both the multiplexers will be selected. Then according to the address, the inputs 1C3 to 1C0, one of these will be available at output Y1. These are the inputs. This pin number 3 to 6. 7 is the output. Similarly here 13 to 10 are inputs. 9 is the output. So you may select at any time one of them or both of them, and if you make both the G as high, that is G1 and G2 as high, nothing will be selected, enabled, and you will get low. You will get output will be low, always low. See here, when any G is high, whatever may be A, B or C data, whatever may be select inputs or data inputs, if strobe is disabled, you will get low. When you enable G, you see, low means enabled. When you enable this, then these values will have value, this, that is, they will be considered. For AB00, that is 00, the inputs are also active low. Okay, then C0 will be selected to output Y. For 01, see again 00, if it is high, it will come high. So means C0 will come here, these two lines, second and third line. Fourth and fifth line, it is 01, so C1 will be selected. Whatever may be C2, C3, it will not be reflected at Y. So like that. It is shortly I have written here, for the in the examination this is enough. I have shown here one part only, first part. So 1G bar, that is enable or strobe input, and the data inputs are 3, 4, 5, 6, that is 1D3 to 1D0. Address inputs are S1 and S0, pin number 2 and 16. Output is 1Y, pin number 7, VCC and ground. So here we have written here, when strobe is disabled, whatever may be address inputs, output will be low. When strobe is enabled 0, according to the value of S1 and S0, output will be selected. Output will become the selected input. So this pin diagram, figure 2, this figure you need not write, this is enough. The symbol of multiplexer is like this: trapezoid, left side the larger side and right side smaller side. So the equation is like this. If you are interested, you can study. See here the internal diagram. You have 4 AND gates to which each input is applied. Then to the same AND gates, the address inputs are also given such that 00, 01, 10, 11, for these values, that will be enabled. Here there is small mistake here, it is, see, this is S0, this should be S1 here. In the internet itself it is given wrong, S0 here, S1 here. So this is S1, then this will be S1 bar, this will be again S1. This is inverter. So according to the value of S0 and S1, only one AND gate will be selected. So the input at that AND gate will come at its output. All other outputs will be 0 0. Now all these are given to the OR gate. So that AND gate's output will come to OR gate or OR gate output. This is the equation. For D0 it is S1 S1 bar S0 bar. For D1 it is, see, output will be AND of all these three things ORed. So OR of and OR of and. Together we will put here enable input. You can see here enable input G or E. There in that diagram it is given as G. In this diagram it is given as E. So E is also another common input to all the gates, all the AND gates. So if E is disabled, then output will be 0. So like that. Try to learn yourself by doing Google search.